Bismillahirrahmanirrahim. So, introduction to Wi-Fi, a topic in which this thing Wi-Fi, most of you must be familiar with Wi-Fi because we are living in an age where Wi-Fi is like part and parcel of almost everyone's life. So, Wi-Fi is an alternative network to wired network, which is commonly used for connecting devices in wireless mode. So you know very well that uh, wherever you go, whenever you go to a new place, you are usually uh, looking for the Wi-Fi router over there, and you try to get the password of that. So this is part and parcel of everyone's life, from people of old age to young kids. So, and we know very well that we connect devices in wireless mode in Wi-Fi technology. Wi-Fi stands for wireless fidelity, and it is a generic term that refers to IEEE 802.11 standard for wireless local networks or wireless LANs. So some of you may be thinking that what is this IEEE 802.11? So we know very well that uh, the corresponding standards of communication that are being set by International Telecommunication Union. And similarly, IEEE is the organization that looks after a number of standards that are related to electrical and electronic engineering. So you can just think of this as a standard that has this number, and this number is basically assigned to Wi-Fi in a broader perspective, right? So IEEE 802.11 standard is basically for wireless local networks, right? Okay, so Wi-Fi connects computers to each other, to the internet, and to the wired network. So it has a multiple sort of application. It uses radio technology to transmit and receive data at a high speed. When we talk about Wi-Fi technology, it has a number of technologies, that are related to Wi-Fi. So you can say that this IEEE 802.11. So under this umbrella of I-802.11, there are number of types of Wi-Fi. And the most significant ones are IEEE 802.11b, IEEE 802.11a, IEEE 802.11g. Okay, IEEE 802.11b appeared in the late 1999. It is a simple 2.4 gigahertz radio spectrum having a theoretical speed of 11 megabits per second within a 30 meter of range, whereas the actual speed is around 4 to 6 megabits per second. The range is around 100 to 150 feet, and it is regarded as one of the most popular and less expensive of all the different types of Wi-Fi's. Interference from mobile phones and Bluetooth devices, which can reduce the transmission speed, is one drawback of IEEE 802.11b. The next is IEEE 802.11a. This was introduced in year 2001. The center frequency in IEEE 802.11a is 5 gigahertz. The theoretical speed is 54 megabits per second, whereas the actual speed is 15 to 20 megabits per second. The range is 50 to 75 feet. It is more expensive than IEEE 802.11b. And the most important thing is that it is not compatible with IEEE 802.11b. So you can see that the specs of, or the specifications of IEEE 802.11a is a lot different from the specification of IEEE 802.11b. So that is why both are not compatible with each other. After that, in year 2003, IEEE 802.11g standard was introduced, It combines the features of both standards A and B. The feed range is from 100 to 150. It has a speed of 54 megabits per second. It can also work in 2.4 gigahertz radio spectrum, and it is compatible with IEEE 802.11p. Reason being that the center frequency of both of them are same. Since the center frequency or the operating frequency of IEEE 802.11a is 5 gigahertz, so that is why it is not compatible with G and P types of Wi-Fi. Okay, now talking about the elements of Wi-Fi network, the most important is the access point. The access point is a wireless LAN transceiver or base station that can connect one or many wireless devices simultaneously to the internet, right? So you usually talk about the router of the Wi-Fi. That basically is the access point, because that is the base station that eventually has to connect uh, a number of devices to the internet. Moreover, it also has a Wi-Fi card. A Wi-Fi card accepts the wireless signal and it also relays the information. So basically accepting the signals and relaying the information via wireless fidelity type of technology. The hardware responsible for this operation is Wi-Fi card. So they can be internal or external Wi-Fi card. So most of the devices have internally installed Wi-Fi card. Safeguards. Firewalls and antivirus software protect the network from uninvited users and keep the information secure. Okay, so what are the different types of topologies that the Wi-Fi can use? The first one is the ad hoc mode or the peer-to-peer topology, and the other is the access point-based topology that is also known as the infrastructure mode. In case of peer-to-peer topology, access point is not required. As you can see from the name, peer-to-peer. So in the peer-to-peer, there is no role of the access point. So in case of peer-to-peer technology, access point is not required. The client devices within a cell can communicate with each other directly. So it is useful for setting up a wireless network quickly and easily. So this is a depiction of the peer-to-peer topology. You can see that there is a mobile phone. The mobile phone is directly connected to this laptop, and this laptop is directly connected to this laptop. This laptop is also connected to this mobile phone. So this is peer-to-peer topology. There is no concept of the access point over here. So if this mobile phone, for example, has a Wi-Fi card, and if this laptop has a Wi-Fi card, both of them can talk to each other via the Wi-Fi. In the infrastructure network, that is also known as the access point-based topology, the client communicates via the access point. So any communication has to go through the access point. So access point is basically that link the multiple devices with each other. So every kind of information has to go through to via the access point. So if a mobile station like a computer or a personal digital assistant or a phone wants to communicate with another mobile station, it needs to send the information first to the access point, and then the access point sends it to the destination mobile station. So in this figure, you can see the depiction of the infrastructure network where we have a router or the access point. So if this mobile phone wants to talk to this, when I say talk to, it means if this mobile phone wants to connect to this uh, laptop, right? So it has to convey the information first to the access point, and then access point forwards that information to the other laptop, for example. And similarly, if this laptop has to connect, for example, to this laptop, so in case of peer-to-peer, they were both connected to each other directly, but here they have to connect to each other via this access point. Okay, so now we are done with the types of Wi-Fi topologies. Let's move on to the next thing that is the hotspots. A hotspot is a geographical area that has a readily accessible wireless network. Hotspots are equipped with broadband internet connection and one or more access points that allow users to access the internet wirelessly. So hotspot can be set up in any public location that can support an internet connection. All the locations discussed previously that I've initially talked about is an example of a hotspot that wherever you go, you first look for the Wi-Fi. For example, in your university, when you go to your university or your classrooms, right, your mobile phone or your laptop is connected to the Wi-Fi device that is a nearby Wi-Fi device. And that Wi-Fi device is eventually connected to the internet via a broadband internet technology. Hotspots can be set up in any public location that can support an internet connection. All the locations are example of hotspots as far as your university or marketplaces are concerned. These are hotspots of the Wi-Fi. A Wi-Fi hotspot is created by installing an access point to an internet connection. An access point acts as a base station, and when a Wi-Fi enabled device encounters a hotspot, the device can then connect to that network wirelessly. A single access point can support up to 30 users and can function within a range of 100 to 150 feet indoors and up till 200 feet outdoors. So this basically depends upon the environment that we are talking about. For example, if there is some kind of mountainous area or having large number of trees or very near to the airport or something like that, obviously the terrain does matter. But this is a general rule of thumb that usually when we're talking about the indoors, it is around 100 to 150 feet and 300 feet for the outdoors. Again, depending upon the type of the access point that you are using. Many access points can be connected to each other via the Ethernet cables to create a single large network, right? So number of access points can be connected to each other via the Ethernet cable. So that can make even a larger kind of a network. So you can see over here, we have a Wi-Fi device, the laptop is connected to that, a mobile phone is connected to that, and eventually this Wi-Fi device is connected to the internet. So you are browsing the internet, so that information is eventually being relayed via this Wi-Fi router or the access point. There are a number of advantages of Wi-Fi. You know very well that mobility is the first and foremost thing, that is the mobility. It is very easy to install. You don't need to be a computer science specialist or an engineer to install a Wi-Fi device. It's quite simple, uh, quite flexible. It is also cost effective. The information being relayed is secure, and also therefore reliability and security is incorporated. It uses the unlicensed part of the radio spectrum. This is very important. So in the radio spectrum, we don't have a liberty to use any kind of frequency. So obviously you need to purchase or buy the frequency, and millions and billions of dollars are uh, required for that. And you know very well how the countries auction their if you consider your own country, 3G was auctioned and then 4G, and now the talk about 5G, right? So you need to buy the spectrum and you need to get the license of that and then use that. Whereas this Wi-Fi use the unlicensed part of the radio spectrum, right? And therefore it is available for everyone. Roaming and speed, obviously, you know that it is quite good in that. Limitations, interference is one issue, but that is being incorporated as as the technology is getting improved. And similarly, the Wi-Fi technology is also getting improved with time, right? So interference is one aspect that is being looked into whenever a new version of the Wi-Fi is launched in the market. The degradation in performance is also an issue. For example, yeah, you have a very high speed internet, but if you have the Wi-Fi device is compromised or not good quality, obviously you will get a degradation in the performance. High power consumption, again, that is also being getting improved with time, and limited range, obviously. Wi-Fi has a very limited range. You have seen that earlier when we were studying IEEE 802.11 A, B, and G, that there's a limitation in the corresponding range. Okay, so moving on. So let us conclude that the Wi-Fi is a simple and cost-effective way to connect to the internet without the need of the wires. It is growing in popularity because of decreasing cost and the freedom it is giving to the user. So it is, part and parcel of everyone's life these days. I have included this information related to ISM band. This is very important. Most commercial wireless devices, for example, mobile phones, telephones, radio, use licensed radio frequencies, right? So there's a license associated to that particular frequency, right? So large organizations pay that licensing fees for the right to use those radio frequencies. It's not that you're sitting in your home and you start making a transmitter or a receiver, or just let me put it simple, you're making a transceiver that is working at some XYZ uh, gigahertz, for example. It's not that simple, right? Because the organizations, they have to pay the licensing fees in order to use radio frequencies. But Wi-Fi uses the unlicensed spectrum. It does not require any license. License fees are not usually required to operate the Wi-Fi equipment, right? You just need to purchase the Wi-Fi equipment and then use that. The industrial, scientific, and medical. This is also known as the ISM band. It allows for unlicensed use of the 2.4, 2.5 gigahertz, 5.8 gigahertz, and many other frequencies. So if your device is operating in the ISM band, you can use that without purchasing the corresponding license of that. So this is very important. So the organization that set different kinds of standard, right? So they have defined a certain bands of frequencies, certain ranges of frequencies that is considered the ISM band, and that is usually for industrial, scientific, and medical bands, and it allows for the unlicensed use of these kinds of frequencies. Okay, 802.11 family. We have initially talked about A, B, and G. On the same lines, we also have N, AC, AD, AF, AH. These are all the frequency bands that fall under the umbrella of the IEEE 802.11 variant, right? Okay. Okay, 802.11 family, for example, the lower frequency in megahertz 2400, the upper frequency is 2500. So this is often referred to as a 2.4 gigahertz band. This spectrum is the most widely used of the available bands for Wi-Fi. It is used by 802.11b, G, and N, and can carry a maximum of 3 non-overlapping channels. I will talk about this overlapping channel shortly. And similarly, 5 gigahertz band or the 5.8 gigahertz band, it has a lower frequency of 5725 megahertz to 5875 megahertz. It provides additional bandwidth, and being at a higher frequency, equipment cost similarly is higher. Although the user interference is less, it can be used by A and N variants. It can carry up to 23 non-overlapping channels, but it has a shorter range than the 2.4 gigahertz. Okay, so regarding the speed and the bandwidth, we have talked about that earlier as well. Let me tell you about the IEEE 802.11n variant that can support up to 600 megabits per second. That is significantly or many folds greater than the variants A, B, and G. And it uses the 2.4 and the 5 gigahertz unlicensed band. Usually, WiMAX is also sometimes confused with the Wi-Fi. Please note that the WiMAX is 802.16 standard and not the 802.11 standard. And it is a completely different technology that uses a variety of licensed and unlicensed frequencies, right? So WiMAX is a totally different technology. So this table is showing us the compatibility of the standards uh, with regards to the different access points and clients. For example, if you have access point that uses 802.11a and the client is also using 802.11a, then obviously both of them are compatible with each other. Yes. For example, if your access point is 802.11g and the client connected to that is 802.11b, yes, they are compatible with each other, but it will have a bit slower speed as compared to, for example, this 802.11g connected to 802.11g, right? And similarly, 802.11a, for example, is not compatible with 802.11b, right? So both of them are operating at the different frequencies. How can they be, um, you know, compatible with each other? So this table is actually showing us how the compatibility of the two different kinds of Wi-Fi devices is there, right? So let's sum up all the different variants of the Wi-Fi. So Wi-Fi standard A, B, G, the N standard that we have just talked about is also known as Wi-Fi 4. So that was adopted in the year 2009. As we have just seen, it has a significantly higher data rate of up to 600 megabits per second. It can operate in both 2.4 and 5 gigahertz band and introduced MIMO technology as well. So multiple input, multiple output technology, having a number of multiple antennas instead of having a single antenna. Then we have 802.11 AC that is also quite famous and called as Wi-Fi 5. That was launched in year 2014. So it operates exclusively in the 5 gigahertz frequency band. It offers the higher data rates up to several gigabits per second, improves reliability and greater channel bandwidth of up to 160 megahertz compared to 802.11n. There's another standard 802.11 AD. This is also known as Y-Gig. It operates in the 60 gigahertz band and can achieve multi-gigabit speed, but it has a very limited range and cannot effectively penetrate wall. So this is quite a significant issue. And since there is the issue of the through wall communication, so the application of 802.11 AD is very less and confined to only a few applications. And then we have Wi-Fi 6 that was released in year 2019. Again, it operates in both 2.4 and 5 gigahertz band. And in terms of data rate, it reaches up to 9.6 gigabits per second. And the performance is significantly improved. And then we have 802.11 AY. This is also the extension of AD. This standard is still in development. It aims to provide data rate of up to 40 gigabits per second and a range of 60 gigahertz Wi-Fi. And then we have Wi-Fi 7. This is the future standard expected to be finalized in year 2024. It aims to further improve the data throughput, potentially above 30 gigabits per second, latency and efficiency operating in the 2.4, 5 gigahertz and the 6 gigahertz frequency band. So this is not yet launched in the market. So this is something that is in the offing and will be available in the years to come. Okay, a very important question that I have added over here. So what happens if a number of people are connected to the same Wi-Fi router? So what is the thing that happens? This is you can say a typo where I have written 10. You can say when the a number of people are connected to the same Wi-Fi router. So you can say that it's not 10 actually, it's actually more than 10, depending upon the type of Wi-Fi. You can say that when many people are connected to the same Wi-Fi router, what exactly happens? Okay, so several things can happen affecting both the performance of the Wi-Fi network and the user experience. Here are some considerations. Bandwidth sharing. The Wi-Fi bandwidth is shared among all connected devices. So if many devices are using the network simultaneously, especially for bandwidth intensive tasks like streaming video, gaming, or large downloads, each device may experience a much lesser speed. So you must have seen this, that if you go to a place where which is quite crowded or where there is network congestion, you experience a lesser speed. In case of network congestion with many devices connected, the network can become congested. This means more data packets are trying to travel through the network at the same time, leading to potential delays and even packet loss. You can just create an analogy with a road. For example, you're going on a road and there's too much of traffic on the road. Obviously, then each traveler on the road will eventually has to slow his speed, and the time to reach the destination would be quite uh, significantly more. Interference and signal strength, the more devices that are connected, the more wireless signals are being transmitted and received, which can increase the likelihood of interference. Also, if all users are spread out in different areas of the house, devices farther away from the router might experience weaker signal strength that leads to poorer performance. So obviously, uh, at your homes, you must have seen that when you go out of your home, uh, as you go away from the access point, your quality of connectivity is degraded. The router capability is very important. The performance impacts depend upon the capability of the router. Modern routers, those designed for high traffic, can handle multiple connections more efficiently than the older basic model. This is kind of a you can say a bottleneck. So if your router is not capable enough, even if that router is connected to a very high speed internet, so since that bottleneck is being created by this Wi-Fi device, so you will experience internet of far lesser quality. Quality of service settings, some routers allow you to prioritize certain types of traffic or devices through quality of service setting. This can help ensure critical activities like video calls or online gaming are not negatively impacted by other less sensitive activities like background file downloads. So you can also prioritize your setting. Impact on specific devices, activities that require real-time data transmission like video conferencing or online gaming may suffer more noticeably in terms of lag or interrupts. In contrast, activities like web browsing or email may be less affected, obviously, because of the type of activity that you're performing. Obviously, that is more challenging, this video conferencing or online gaming. Security considerations, with more devices connected, obviously, there is an increased need for robust network security, as each device represents a potential entry point for security threats. So proper security measures becomes more critical. So this is a very important thing, that what happens if more devices are connected to the same Wi-Fi network, right? Okay, so as you know that, and we have also talked about this earlier, that in Wi-Fi there are a number of channels. So in the 2.4 gigahertz frequency band, commonly used by the Wi-Fi standard like BGN, there are typically only three non-overlapping channels, 1, 6, and 11. In most countries, these channels are spaced far apart that their frequency bands don't overlap, right? So there are a number of frequency bands. Let me show it to you using another document. It will be more clear to you in that case. Okay. So you can see this. So this is how the Wi-Fi channel looks like. So this is basically example of the IEEE 802.11b, in which we have each channel is of 22 megahertz, right? So this is the center frequency and it is occupying a certain range, right? So a band of 22 megahertz centered at 2.4 gigahertz, right? And similarly, we have channel 2, channel 3. So you can see that the channel 1 and channel 2 is overlapping. And similarly, in the channel 1 also, you have some part of channel 3 and channel 4 and so on and so forth, right? So actually, when we're talking about this, so usually this channel 1, 6, and 11 is non-overlapping, right? So if the neighboring Wi-Fi networks are set on overlapping channels, for example, channel 2 and 3, and for example, 6 and 9, they can interfere with each other. This interference can degrade the performance of the Wi-Fi network by causing increased latency. When we say latency, it means how much time the device is taking to respond to you, reduced data rates, and network instability. Talking about the 5 gigahertz band and overlapping, the 5 gigahertz band used in the newer Wi-Fi standards has more non-overlapping channels, so obviously better performance. This reduces the likelihood of the interference, and it's one of the reasons why the 5 gigahertz band can offer better performance, especially in the crowded environments. So choosing the right channel, it is the Wi-Fi router can often automatically select the best channel to minimize the interference. In some cases, especially in the crowded environments like apartment buildings, it might be necessary to manually select a channel that has less interference from other networks. So usually we don't care about this, as it is automatically, the channel is automatically assigned by the access point. When Wi-Fi channels overlap and interfere with each other, it can lead to packet loss, reduced data throughput, increased latency. This is because Wi-Fi devices have to wait for a clear signal before transmitting data, leading to network inefficiencies. Modern Wi-Fi standards allow for wider channel widths. While wider channel widths can provide higher data rates, they also increase the potential for overlap and increase in the crowded environments. Okay, so Wi-Fi router, there are several factors that are contributing to the positive outcome that we usually don't get to see too much of trouble. That is because of the high quality router, the good network environment, the bandwidth and the usage patterns, the effective channel utilization. We usually have dual or tri-band routers. For example, your router is operating at a multiple frequency band. It can spread the devices across the devices to balance the load and minimize interference. Robust signal strength and less intensive internet activities, these all contribute to a better performance of a Wi-Fi access point. So this was all that I wanted to cover regarding the topic of Wi-Fi. Thank you very much.